I just want to start this video by showing you why I think I was wrong about AI agents. So I've always been very skeptical, and the test I have done in the past was not perfect because it always failed at some stage in the planning sequence, right? But after trying this with O1, yeah, I have changed my mind. Just to show you what I mean by this is here we have a list of 15 different instructions. I haven't even tried to push it further yet, but we might do that in this video, we'll see. So let's go through some of the instructions here we're gonna feed to our agents. That is gonna be masterminded by O1, of course, to lay out the plan. So we're gonna find the sum of the following numbers, right? The total sum of the numbers should be divided by 3 to find the final number. The final number is the number of hamburgers that should be in the image. The image should have the style of a painter of the most famous piece in the most famous museum in France. We're gonna generate some HTML code. We also need a second image. That should be from the tallest building in a city that most people associate with a big fruit, taken by a 1950s photographer. To find the number of the people in this image, we must divide the number associated with Titanic by 450, round down to the nearest whole number. We're gonna go through some more instructions here. The customer wants to style the art piece HTML code to look like a 1950s website with extremely good readability. And we need to add some information to the art piece HTML. So there's a bunch of different instructions here. So our master agent now, O1, is gonna plan out each step. It's gonna feed to our different agents. So I don't know if you can see this, but we have a code agent, we have a file agent that uses function calling here to execute the stuff. And we have an image agent that can generate images using Flux. But that is kind of, yeah, how you set up different agents. But I think we're just gonna run this now. So let's run our master agent code here and paste in our task. So you can see this is our full task. So what's going to happen now when I run this? O1 is going to start to create a plan here that is going to be sequential instructions that we will give to our agent in JSON format. So yeah, I'm just going to skip ahead. This takes a bit of time with O1 preview. So I'm going to show you when we have the plan, sequential plan laid out here. Okay, so you can see here now, here is what O1 planned for us, right? So the first thing is gonna send a prompt to the image agent that's gonna generate an image of 3 burgers in the style of Leonardo da Vinci. It figured out here that the most famous painter in the most famous museum in France is Leonardo da Vinci. And the second instruction is to call upon the file agent that needs to download the generated image and save it as hamburgers.png. You can see we already have that saved here. Yeah, 3 burgers, perfect. Okay, that's good. And you can follow along here. Here is the sequential step. Then we're gonna generate some HTML code. We're gonna save this code. We're gonna generate an image taken from the top of the tallest building in New York. So they figured out that the Big Apple was New York. 4 people, that is correct. Because we divide 1912, that is associated with Titanic, by 450, and we round downwards, that's gonna be 4, in the style of a 50s photographer. We're gonna download this file, we're gonna write more code, style the code, save the code, modify the code to display side by side, and we're gonna end up with art piece HTML, right? So if we scroll down here now, we can see all the steps the agent is doing. We are generating or executing code, right? And this is just gonna keep continuing. You can see we have some HTML code here that is gonna be the final result of those 15 instructions. So I'm just gonna let this run now, and we're gonna see at the final result is actually what we put into our instructions. Okay, so you can see the final code has been successfully saved as art piece HTML in the CVD. Perfect. You can see we have art piece HTML here. If I move my camera a bit, now you can probably see it. Here we have art piece.html. So let me open this now in a live server and let's take a look at it. So here you can see, here is art piece. So you can see 1950s art piece gallery, experience the charm of classic photography and art. We have our 2 images, view from the top of the tallest building in New York, 3 hamburgers in the style of Leonardo da Vinci. I don't know if that was correct, but we got our website, right? Looks pretty good. And I think it actually, yeah, that's the 1940s photograph. And I think it actually followed every single instruction we gave it here. And I haven't even started looking at how far we can push these instructions. But in today's video, I kind of want to go through how I set up this agent agentic system that has different agents that we can add more functionality to. We can expand this as big as we want. So that is going to be the main bit of the video today, and we're going to try some different instructions to see how far we can actually push this. So if you're not interested in learning how I set this up in the code, you can just follow along down in the video. I'm going to make some stamps here that you can skip forward if you just want to watch the results of me running the code with different instructions. But if you want to learn something here, just stay, and I think we're just going to go through the master agent, and we're going to take a quick look at the smaller agent that he calls on, or it calls on. Yeah, I'm not going to go through the dependencies here. You can see it on the screen here if you want to, right? But what we start with here is, of course, the planning prompt, because this is very important. So this is something I spent actually a bit of time to set this up, because yeah, I had to adjust it a bit, but it wasn't too hard to set this up. So if you take a look at the planning prompt here, we're going to take the user task as an argument here. And this is going to be the first, we might zoom in a bit here, maybe that's too much. That is going to be the first step in our prompt. And we're going to feed some instructions. So as the master agent, you need to create a very precise plan to complete the task by utilizing the following agent. So these are the agents that I have available now. That is going to be the image agent, the code generation agent, and the file management agent. We can take a quick look at them, but basically the image gen agent can create images based on text prompt. Both the code generation agent can write and execute code. So the way we do this is we use the OpenAI Assistant API, and this has a tool that is a code interpreter. So we can actually use the code interpreter to execute code using the API. So I found that was very helpful actually. Instead of setting up my own way to execute code, we can just call upon the code interpreter if we need that, and we can execute code that way. That has been working very good. So I'm kind of bummed I didn't do that before. Other than that, we just have a classic assistant API here. So we create a thread. We add the prompt to the thread, we run the thread, and we have like a true loop until we have completed this. And yeah, you can dive more into this agent, but we have some things set up here. I'm not sure if I'm gonna dive too much into it, but sometimes we want to execute code, sometimes we just want to write code. That's the way I set this up. We might look at that after, but I have like an instruction here. So you're an expert programmer. Write code to accomplish the user task. Yeah, it's pretty standard. But the most important thing here is that we set up the tool here, code interpreter. So we don't have to explain this more. And we have this in this list here. We have the tool, and we use the GPT-4o model to handle the instructions. That has been working pretty good too. The file agent is a bit different. Here we have to create our own tools. So we have 3 functions. So we're going to write file, that is to write to the CVD. We have a function that is can download images using request, and we run assistant. I made a read file, so we can also read files here. So here you can see your file management assistant. So this is just the instructions. You can read and write files and also download images. Just put that down. And the tools here is gonna be function calls. So we have the read file tool. So I should spend a bit more time on the description here, but I kind of skipped that for now. But we have the read file tool or the function. We have the write file function. That is also going to be a tool, of course. And we have the download image function that uses pillow and request to actually download from a URL or to a file path. You can see we have a URL as argument here, and we have a file path. So we can take a URL, download the image, and get that into our CVD. So this is the file agent. Here we can, of course, add a bunch of new functions if we need more tools. So it's very flexible. I think we're going to add some more tools to our system at the end of the video to just to show you how that works. Other than that, it's pretty much the same. We have some tool outputs here, and I'm not gonna go spend too much time diving into that. The funnel agent is pretty straightforward. It's just a replicate API that calls up on the Black Forest Labs Flux dev using replicate. This is also passed in as a function call, as a tool to generate an image based on the user's prompt. So basically here, the master agent creates a prompt based on the task and sends this prompt to the image agent, and it will get a URL back of that image. So that is also something you can dive more into if you wanna create your own. Because I will be adding this system to my community GitHub. So if you become a member of the channel, you get access to that and you can play around with this. But now let's continue with our master agent here. So remember, I set up all the agents here. So now we kind of know what they do. And we're going to determine which agent to use. That is kind of based on the user task. And we're going to specify a plan in a JSON format. So the structure is going to be, we have a key plan, we have a key agent and an agent name and a key prompt and a prompt for the agent. So this is very important because this is our sequential plan we're going to execute. All right, and we have some rules for this. So remember, you can only use each agent once at a time. I mean, so if you need to use an agent more than once, you must include that in the plan. Images, image agent can make images but not save them. File agent can save, read, and download files but not make images. So I just want to clear that up. So only include agents necessary for task, do not include code blocks, be very precise, don't include backticks, right? Must be valid JSON. Of course, I could, implement structured outputs if I wanted to. But for now, I haven't tried that. We are running the O1 preview now, but the O1 mini also works pretty good. So the only thing that's kind of bad here is that we don't have a system message. So we're just going to have feed everything through the prompt. So that might change in the future, right? We are using some regex to actually parse the plan. And if you throw an error, so this is very important. So this is the context part, because we need to store the outputs from the agent so we can use them. Some tasks are dependent on the answer from the previous task, right? So you can see we have context from previous agent. So this is going to be stored in the context list, right? So that is very important here. And we also have results. So these are the result that is going to be stored in this dictionary from the agent. This is going to be run in like a for loop. So yeah, like I said, I'm not going to spend too much time going into very specific details of the code. You can do that if you want to try this out for yourself. But the most important thing to know is that it's very important to include the context from the result from the agents we run, so we can bring that over to the next agents, especially when we set up this sequential plans that depends on the information from the previous agent. But that has been working very well, right? And you can see here, like I said, I'm not going to spend too much time. It's a bit boring. You can just, if you want to, you can just study this a bit more yourself. But it is pretty much straightforward after here, because we call up on the agents, right, with image, code, or file to actually determine if the agent name is file, then we're going to do this. That is taken from the plan, right? So did we have an example of how the plan looks? So if we go up here now, you can see we have the key plan here, right, in the JSON. And we have the key agent. So this is going to be the image agent. That means that the first step is going to be to call the image agent, right? So if the agent name lower is image, yes, it is, right? Then we're going to pass agent prompt. This, right? So this is going to be the agent prompt to this, and we're going to store the result in result, and we're gonna store the context that we get back from this agent, right? And if the lower code is code, we're just gonna do the same thing, right? The next here was file, so hopefully that is pretty understandable, right? And you can see all the spinners and stuff. That is basically from the rich library. But what is very interesting about this way to set up agent is that it's very dynamic, and it's very easy to add more features by just expanding these. Let's say we add a new function here. This could be calling an API, anything, right? And we can just add this to our tools list here. And we can just continue building out our system to do more and more advanced things. So I'm going to keep exploring with this, but I found this very interesting, and I was very surprised by the results, because everything relies on how good our O1 model structures the plan. Because if this fails, if the plan here fails and is not precise enough, then nothing's going to work. So this is kind of what changed for me. Because before, when I tried to do this plan here was never really good enough. But the results I have so far with O1 has been pretty good, and I've been super happy with how it turned out. But I think that's enough for the code for now. And I think we're just gonna try some more examples to actually see what else we can do. And we're gonna add some new tools to see if how we can implement that. Okay, so I think what we're gonna do is we're gonna create a weather agent so we can actually expand upon this. So I'm just gonna show you how we can do this. So yeah, I went to open weather, I got the API key. So let's head back here now to cursor. So let's just, let me write a prompt here to actually create this agent here. So you can see here, I'm just gonna reference our image agent so we can actually use that as a reference. So we need to create a weather agent, use the same format as the image agent. We're going to use the Open Weather Map API to fetch the weather for the next 3 days in a set location. I have the API key stored in env as Open Weather Map API key. Create the weather agent Py code for me, please. Okay, so we're going to use 3.5 Sonnet for this. So let's just generate and see if, yeah, that looks pretty good. Okay, so we have the gather weather forecast. We're using the key. Metric, I like that. 3 days forecast, okay, that's fine. Temperature, description, weather, okay. Run assistant, yeah, we have the tool that is gonna be get weather forecast. Yes, I think this is good. So we're gonna try it. That was 119 lines. Now we have to go to our master agent, right? Let's do Control L here. And let's add in our weather agent, and let me do a prompt here. So let's just do update at masteragent.py to include the weather agent.py in the agentic system, please. I think I'm gonna try that and see if we actually can update our prompts here. Yes, it does include the weather forecast agent. So this is what's so good about Cursor. Since we already have a lot of context, this makes it super easy to actually implement more features. This would have taken me much more time if I had to use like ChatGPT or write this myself. That would take forever. But let's see now. So let's add this new code to our master agent. Okay, so we're gonna import this. We're gonna add a new, yeah, good. I think that's enough. Hopefully we also get a new section here. Yes. So else if agent lower than weather. Yeah, perfect. Yeah, that's good. I think that's it. That should be it. So let's save that. And now let's write a new instruction list for our agent. I have some ideas, so let's clear this and let me come up with some new instructions so we can actually test our new weather agent. Okay, so this is gonna be the instructions. So we're gonna find the weather forecast for the next 3 days in Oslo. From the given weather forecast, create an image that best represents the weather. Add some text to the image to describe the weather in 1 word. Download the image to my CVD. So let's grab these instructions. Let's run the master agent down here. Okay, let's paste in our task. Good. And now let's see together now what the plan is gonna be. So hopefully it's gonna be to call the weather API. I haven't tried it yet, so hopefully it works. Then call up on the image and then call up on the file agent, right? Yeah, I'm gonna take you back when we have the plan here. So you can see we are gonna call the weather agent, provide a, yeah, that's good. Create an image that best represents the following weather. Insert weather forecast here. Is that gonna work? Maybe. Add some text. Okay, so it found the weather forecast. Clear sky with temperature of 11. Overcast, light rain. Oh, that's gonna be hard to do an image for. So I'm kind of interested to see what kind of prompt it's gonna actually feed the image now. If it's gonna change this, or this is just gonna be very generic, right? Okay, so it created 3 images, so it's gonna be clear sky, overcast clouds, light rain. Okay. And then, okay, so we got 3 images. That's pretty cool. So let's take a look at the images. So remember, tomorrow is, or today is gonna be clear sky. Okay. Tomorrow is gonna be clouds. And then it's gonna be light rain. Okay, not too bad. I thought that was pretty good, and that worked first time. So yeah, pretty cool if you ask me. And it's just your imagination that kind of stops where you want to go with this. That was just something I came up with, and I think it executed pretty well. We can just turn this into a report if we wanted to, right? We can just add, let's say, download the images, create the images maybe, right? To the images, and let's do, we can add, write a weather report that includes the images, maybe. The images as a .md file to my CVD. Okay, so let me try to run this. I'm not gonna let you go through every step, but let me run this command and let's take a look at the result. Okay, that was done. So we have the weather report MD. So let's do a preview of this. Okay, so you can see the weather report. Here's the September 29th, that's today, clear sky. The image was a bit bad. Next day, 10 degrees overcast clouds. 12 degrees, light rain, day 3. And that was the weather report. Yeah, I'm just so impressed by this. I think it works super well. And my brain started thinking, what else can I do? What else can I do, right? So I need to think about this for a while now and come up with some new super cool AI agentic project we're gonna do, because I think this can open a bit my mind of what we actually can start doing now when we have these good planning capabilities from the O1 model. Yeah, let's do just a few fun things at the end before we kind of call it. Okay, so here's gonna be the final challenge. So we're gonna use code to find the square root of 9. The square root of 9 should be the number of spider pigs Homer Simpson is walking down the street in the generated image. We also need to find out when Simpson's first episode aired. Generate code to include the image of Homer Simpson plus some information about the first episode in an HTML website named simpsons.html. Okay. Store the HTML website as Simpsons. Yeah. We need the weather forecast for tomorrow in Springfield, USA. Based on the weather forecast, create an image of Bart Simpson skating in this weather. Update the HTML website with the image of Bart plus some information about the weather, and store it again. So that is gonna be the task, right? Yeah. What happened there? Yes, that is correct. Okay, so let's grab this instructions here. And let's fire this up again. Let's enter our task. Let's see if we can actually do this. Okay, so you can see the agent are working now. So now we're gonna find the square root of 9. Here's an image of Homer Simpson working on the street with 3 spider pigs. Perfect. Okay, so we saved this as... oh, it was only 2 spider pigs, but they were pretty cool though. That was a bit of a fail. And then we are... To find the first airing date, leverage like Wikipedia. Oh, that was not good. Okay, that's fine. But let's just let that run. Now we're gonna generate some information. We're gonna include the image. Okay, so I found the date. So it was December 17, 1989. We have the Homer Spider Pig image. The weather forecast for Springfield is 16 degrees, clear sky. Here's an image of Bart skating in sunny weather with a high... Oh, that was not too good. But we got the Bart skating. Okay, I guess it's snow. Was supposed to be sun, but that's fine. Then we got the HTML page. So let's take a look at the page. Okay, so we have The Simpsons, the first episode. We got Homer. The weather forecast is sunny with a high 75. Why is he on snow though? Anyway, I think that was pretty okay. Of course, we could have worked much more on the prompt, but like for our first one shot, I thought that was pretty cool if you ask me. But yeah, a lot of fun stuff to explore here. Super happy with my agentic approach to this. Super happy how I constructed my prompt and kind of how I planned this out. And I think there's just a bunch more of stuff we can do with this. So I'm gonna keep exploring this week. What else can we do? Can we actually turn this into something useful? Do you have any ideas? Please leave them in the comments and I will try to implement them. This was just, yeah, to get things going and start thinking about what kind of APIs can we integrate in this? Can we bring in maybe some stock analysis? Can we do some, yeah, there's a bunch of things floating around in my head, some ideas, but I would love to hear some ideas from you and what you think about this. Is this something you wanna try out? That would be pretty cool to hear. And yeah, are you impressed by O1 preview? What do you think about its planning capabilities? That is kind of what I found most interesting about this, how well it follows instructions. And it doesn't seem to make those annoying hallucination errors, small things that it used to do before, because it's using this chain of thought, step-by-step process, right? So the planning has been superb. It always kind of does the same good structure when we need to generate this plan, right? Some weird stuff here, but weather.html, sorry. Okay, so I messed that up. Yeah, that was my bad. Other than that, yeah, pretty cool stuff. Excited to work more on these AI agentic systems. I think there's a future here, to be honest. I guess I was wrong. I was very negative about this at least a year ago. But this has kind of changed my mind on it, and I'm going to be more, yeah, eager to try things out now. Like I said before, I was always waiting for a model that thinks it needs to be to actually make this work. But this is looking promising, so I'm definitely going to check it out more. Yeah, thank you for tuning in. Hope you enjoyed it. Hope it gave you some ideas. And like I said, if you want access to this full code, become a member, and I will invite you to GitHub. See you soon.